So let's first talk a bit about sensitivity. This is, of course, a subjective term also, and we could start like comparing those two situations. On the left-hand side, you see schematically depicted again surface plasmon resonance, where you see that with a light beam, with a laser, we would hit a gold surface in a certain angle, and we would create these name-giving surface plasmons on the surface, which would be able to see and sense changes in the refractive index in a localized field here. As we go to the right-hand side and we're looking at waveguide interferometry, it's also, of course, an optical readout, an optical method in the end, and it works with a field. However, the light is here carried in, or it's coupled into a solid structure, which we call a waveguide. And running through that waveguide, it creates an evanescent field into the measuring area onto the surface, and this field is running continuously over the whole sensing area and is able to pick up refractive index changes, in the end binding of molecules, the presence of molecules. However, having a continuous evanescent field being present on the surface, we're able with this setup here to catch up more events, more binding events, and therefore get to a higher signal, which means a higher sensitivity. What Creoptix actually developed then as a proprietary technology is the Grating-Coupled Interferometry. We abbreviate with GCI. And the point here, or the trick here, is that we're actually coupling in the measurement beam via a grating here. So that's a microfabricated structure that is able to diffract light and eventually then couple in light into the waveguide here. And we couple in a reference light beam via another grating into the very same solid structure, into the very same waveguide, which makes the system very robust and very stable and enables us to read the phase shift. So in the end, we're measuring interference, we're doing interferometry. In the end, with this setup, having both light beams traveling in the same waveguide, measuring phase shifts, so the interference with a very high robustness and precision here.